Hello and welcome to the second video on power functions. Just as in the last video, we have this power function y equals 3x to the 1.3, and as in the last video I commented that any function of the form y equals kx to the n is a power function, and our function certainly is that, where k is 3 and n is 1.3. In the last video I gave a numerical explanation. I'd like to do an algebraic one this time. Since this problem is usually given in college algebra, it makes sense that we use some algebra to solve this problem. So unlike the last problem where we chose x to be 1 and then we chose our new x value to be 2.5 to indicate that we are to increase x by a factor of 2.5, I'm going to do the same thing, but I'm not actually going to specify what numbers I'm going to choose. This actually can be chosen arbitrarily. So for example, somebody could pick x equals 10 and then 25, hence multiplying by a factor of 2.5. I'm going to do none of that. What I'm going to do is plug in x equals a to not specify a specific number. I'm just going to say a is the number that we plug in. Then, since we're supposed to increase x by a factor of 2.5, that means multiplication, our new x value, like this is x of 1, this would be x of 2, would be our old x value, a, but multiplied by 2.5. So I'm going to plug in a, and then I'm going to plug in 2.5a, hence increasing x by a factor of 2.5. When I do that, remember this is my equation, it's going to look like this. Replacing x with a, I'm going to get 3 times a to the 1.3. So that's my first y value. My second y value, you can think of as your new y value. What would my new y value be if I instead plugged in 2.5a? So where I see x, I'm going to replace it with 2.5a. So this time I'm going to get 3 times 2.5a to the 1.3. And my job is to compare this y value with this y value and see by what factor y increased. So the theory is, because this is a power function, it's not really a theory, every time you induce a multiplicative change in your inputs, there'll be some corresponding multiplicative change in your outputs. So to see what it is, let me multiply this out, sort of in an order that you probably wouldn't do. We have the 3 here, which I copied, and then since the a is in the parentheses, it's most decidedly being raised to the 1.3 power. But what's new is this 2.5. We had a 3 before, we had an a to the 1.3 before, but now what we have, since we multiplied our input by 2.5, is we have this new factor of 2.5, but it is the input, and the function says to take the input and raise to 1.3. So by putting a 2.5 here, we didn't just introduce a 2.5 into the equation, we plugged in, or we introduced a 2.5 raised to the 1.3. So if you just to take a careful moment here to compare the old y value with the new, they're almost identical. If you compare these two things, they are the same. So the only thing that's new by changing a to 2.5a is this guy right here. So my y will change by that multiplicative change, and if I go to my calculator and clear this, you'll notice if I take 2.5 and raise to the 1.3, we'll get the same answer we did in the previous video where I did the explanation numerically, that every time a increases by a factor of 2.5, y will increase by a factor of 3.9, I don't know why I have such a short-term memory, 3.29095, 3.29, I guess. It says 3 decimal places, but when I'm working with math AS I usually give 4, so 3.290 would probably work. Actually, that would be 3.291 if you rounded. But if you want to be careful, you should round it to 3.29096 when you type it in math AS. So this is just a different way of getting the same answer we got before.